Students, welcome to this 12th lecture in chemistry. Today we are going to discuss another colligative properties, that is depression of freezing point. Now what does it mean by depression of freezing point? The freezing point of a liquid is lowered when a non-volatile solute is added to it. That means, for example, suppose we have taken water. The freezing point of water, as you know, is 0 degrees Celsius. But if sodium chloride will be added to it, then its freezing point will be lower than 0 degrees Celsius. So when a non-volatile solute is added to a liquid, then its freezing point is decreased. That is known as depression of freezing point. So what is meaning by freezing point? Freezing point is the temperature at which the vapor pressure of the liquid phase is same as the vapor pressure of the solid phase. But when a non-volatile solute is added, then the vapor pressure is lowered. That is why the freezing point also lowered. This decrease of freezing point is known as depression of freezing point. Let us look at the computer screen. Now depression of freezing point means lowering of freezing point. What is the freezing point? Freezing point is the temperature at which the vapor pressure of the substance in the liquid phase is equal to the vapor pressure of the substance in the solid phase. Remember, freezing point is the temperature at which the vapor pressure of the substance in the liquid phase is equal to the vapor pressure of the substance in the solid phase. Now look at the curve given in the figure carefully. Now in this figure we have taken the vapor pressure along the y-axis and temperature along the x-axis. Now here we have the red line. This red line curve represents the vapor pressure of the pure solvent, that is the liquid solvent. Now this brown line represents the vapor pressure of the frozen solvent, that is the solid solvent. So at point A, the vapor pressure curve of the liquid solvent meets the vapor pressure curve of the solid solvent. So point A is the freezing point of the pure solvent, that is TF naught. Now when a solute is added to a liquid, that means a solution is prepared, then its vapor pressure decreases. So this blue curve represents the vapor pressure of the solution. So this blue curve meets the solid curve at the point B. So B is the freezing point of the solution, that is TF. So A is the freezing point of the pure solvent, that is TF naught, and B is the freezing point of the solution, that is TF. So the difference between the freezing point is known as delta TF, that is called depression of freezing point. So again I am repeating, this red curve is for vapor pressure of the liquid solvent, and the brown curve is the vapor pressure of the solid solvent, and this blue curve is the vapor pressure of the solution. Now A is the freezing point of the pure solvent and B is the freezing point of the solution. So the TF naught is the freezing point of the pure solvent and TF is the freezing point of the solution. So the difference is delta TF, that is called depression of freezing point. So from the mathematics we say that delta TF is called depression of freezing point, that is TF naught minus TF. TF naught is the freezing point of the pure solvent and TF is the freezing point of the solution. So from the mathematics we can say that delta TF is proportional to M. So according to thermodynamics we can have a mathematical equation, delta TF is proportional to M. What is M? M is the molality of the solution, which we have previously defined as the number of moles of solute present in 1 kg of the solvent. So M, that molality, is equal to 1000 into W2 divided by M2 into W1. So W2 is the weight of the solute, M2 is the molar mass of the solute, and W1 is the weight of the solvent. So delta TF is proportional to M. M is equal to 1000 into W2 divided by M2 into W1. So if you change this equation by putting a proportionality constant, so the equation becomes delta TF is equal to Kf into M. Here Kf is the proportionality constant, that is called molar depression constant or cryoscopy constant. So Kf is known as molar depression constant or cryoscopy constant. So delta Tf is equal to Kf into m. By putting the values of m, we get the full equation delta Tf is equal to Kf into 1000 into W2 divided by m2 into W1. From this equation, we have got 5 unknown quantities. One is delta Tf, second one is Kf, third one is W2, fourth one is m2 and the fifth one is W1. Out of these 5 unknown quantities, if 4 things are known, then the fifth unknown quantities can be calculated. So we have a lot of numerical problems in which we can use this equation to calculate the unknown quantities. For example, suppose we want to calculate the molar mass of the solute. So m2 is equal to 1000 into W2 into Kf divided by delta Tf into W1. So if W2, Kf, delta Tf and W1 are given, then you can calculate the molar mass of the solute. So from this equation, we can solve a lot of numerical problem. And thank you for watching this video. Next video follows.